objectives first for our 4.1 on exponential functions, okay? Kaden, can you read the 4 objectives for now?
Evaluate exponential functions, find equations of exponential functions, use compound input formulas, evaluate exponential functions with base
E. Thank you, alright? So at this point, we're gonna deal with 2 of those objectives, right? First, on how to evaluate exponential functions, and second, on how to find equation of an exponential function. We have 2 forms for such. Either we can just use the decimals, right? If you are familiar with exponential regression, that's basically what we're gonna do for such. We also have in here the algebraic way of, or steps of doing that, okay? But for now, let's see first, what is that form? A times B to the x power, right? So we can see in here how it looks like for such. Let's read this one. What is an exponential growth equation for such? All right, Anna, let's go ahead and read this one first.
A function that models exponential growth grows by a rate proportional to the amount present for any real number x and any positive real numbers a and b such that b can't equal 1. An exponential growth function has the form f of x equals a times b to the power of x.
Thank you. Where A is?
A is the initial or starting value of the function. B is the growth factor or growth multiplied per x.
Thank you, right? And B is also called what we call the common ratio as well, right? Now, let's now read the how-tos in here and actually use that one to solve a specific word, a specific problem in here. Here it is. Let's read the instruction for such, okay? Aiden, go ahead, please. Thank you, all right? Let's start in here with number 22. Okay, so in number 22 in there, we got the following, okay? 3, 1 and 5, 4 as our ordered pairs. Let's put it in here. What question number is that once again? 22. Okay. So we got the first point, 3, 1, and the next point, 5, 4, right? So those are the 2 given ordered pairs. As you may notice, I put in the 5, 4 first, and then 3, 1 next. Why is it such a case? Let's read our how-tos in here, okay? And why we wrote that one in that form instead, okay? Adam, let's read step number 1 on how to determine exponential function given points in an algebraic way. Go ahead.
Evaluate y equals a times b x using the ordered pair with bigger x value. Do the same for the smaller x.
Thank you, right? So your equation 1, you always start with a bigger x value. That's the 5, 4. And second, do that one with a smaller x value, which is 3, 1. All right? So bigger x first, this one, okay? So what's the form again? Y is equal to a times b to the x power. So in short in here, this can be written as what? 4 is equal to a times b to what power? 5th power. There, right? So that's our equation number 1 with a bigger x value. Get it? Okay. Now let's do equation number 2. What's this gonna be in terms of that form? Anyone? Bryce, any idea? What's your y in here? 1 is equal to a times b, and what should be the power of b in here? Third power, right? And again, that is our equation number 2. Right? So once again in here, we're starting with a bigger x value, and below it, you put the smaller x value. Get it? Okay. Next, let's read our step number 2, right? Let's read step number 2 for such. Mason, go ahead.
Divide these 2 equations and solve for b. Use quotient rule for exponents.
Thank you. All right. So you're gonna divide equations 1 and 2. So divide on the left, divide on the right. Okay, so for the left, what's 4 divided by 1? 4. Very good, right? What's going to happen to the A? They're going to cancel out. And hence you can solve for B, right? So what's your B now? What's going to happen to the 5 and the 3? According to our quotient rule, you're going to what? Subtract the exponent. Very good, right? So what's the power of B now in here? Olivia? 2. Very good. Okay. There we go. Hence, you got B squared is equal to 4. Okay. Now what's next? What do we do next? Well, we're wanting to solve for B, right? How do you get rid of that power 2, by the way, okay? Sibilai? Any idea? B squared equals 4. You just want the B, right? How do you get rid of the square? Square root, there. Right? Square root this, square root that, right? By, again, method of inverse, right? So hence B is equal to plus or minus 2, but in this case, you always just consider the positive value. Again, in an exponential function, always consider your B or your common ratio to be always the positive value. Get it? Questions, questions, questions? So check, we have solved for B. Next, step number 3. What we're going to do next, right? Jaden. Step 3.
Substitute back this B value to any equation and solve for A.
Alright, in order to solve for A, back substitute, right? So on any equation, right? So choose the easier one, right? So which one is the easier one? Equation 1 or equation 2? 2, right? Again, actually any of those two will be fine, okay? Just plug it in there. What's that again? 1 is equal to A. Your B again is equal to 2, right? And you cube it. Okay. Again, on equation 2, 1 is equal to A times B, which is 2, right? Cube. Get it? Now, solve for A for such. Madeline.
Why did you choose the positive B and not the negative?
Why do we choose a positive B? That's also a good question. A while ago, we said the common ratio according to our summary in here. Your B is a growth factor and growth multiplier, so it's always going to be positive, right? And also you can check on top as well. It will always say that B is always going to be positive. Are we good? Right? But that's a good question in there, Madeline. All right. Anyway, going back in here. Okay, what A value did you get now? Anyone? What A value did you get? Anna? What's 2 cubed?
16.
2 cubed is what? 2 times 2, which is 4 times another 2.
8.
Got it, right? So that means your A is how much?
1/8.
1/8. Very good, right? We're almost there, right? Yeah. Questions? And step number 4. Let's read step number 4 for such. Absalom, go ahead, please. Rewrite.
Y equals A times B to the next power using solve A
And B.
and B.
Values. Thank you. All right. So yeah. So just rewrite this entire expression with your answer. All right. So for A and B, therefore your answer is going to be what? Y is equal to A, which is 1/8, right? B, which is 2 to the X power. Are we good, guys? And the last one, well, definitely you want to, increase your confidence with your answer, right? How do we know if it's even correct? Well, let's plug into your Desmos calculator, right? Once again, Y is equal to 1/8 for A, 2 for B, raise it, right? That's A to the B power, to the X power. Here we go. You see the graph in here, guys? Get it? Now let's see. What are the given points again? Is 5, 4 in there? Let's see. 5, 4. Yes, it is. Okay. And where's the other point? 3, 1. Is 3, 1 in there? Are we good, guys? So again, that is the algebraic way of doing that, okay? Now, definitely you might be asking, is there another way for such? Answer is yes, and that is our regression, right? In regression, this is basically a calculator work. Are we good? Ready with this one? Okay, let's see in here. We got the following in here, and see how we can work for such, okay? Let's read number 24 and, what's this? 24 and 26, and see if it's, how we can get the equation out of it, okay? Reagan, can you see it from there?
For the following exercises, choose whether the table to represent a function that is linear, exponential, or
Or neither, yeah? If it appears to be exponential, all right, let's see. Let's verify first if number 24 is actually an exponential function, all right? So first, what did we say in here for step number 1? Kinsey, go ahead.
Create a table of values.
All right, let's create a table of values for such, right? Let's try this number, let's try number 26 first, okay? So how do you create a table of values? Click on the plus button, upper right, upper left hand corner of your decimals. You can follow along, guys. Good. Click on the table, right? And plug in the values there, right? And what values do we have? We said what? 1, 2, 3, 4, 10, 20, 40, 80, right? Let's put in here. 1, 2, 3, 4, and then in here, what did you say? 10, 20, 40, and 80. Are we good? Get it? Okay, again, this is entirely calculator work. Next, step number 2. What do we do then? Giselle?
Customize the graph accordingly.
Thank you, right? So customize the graph. How to customize the graph? On the upper right hand corner, click on the graph settings. Alright. What's your x value? Minimum and maximum. That's 1 to 4. Are we good? Alright. What's your y value? Minimum to maximum? It says 10 to how much? 80. Right? The goal of this one is definitely for you to see all the points that is put into your table of values. Right? Are we good, guys? Okay. Step number 3. Let's read at step number 3. What do we do? Christian? On the second line.
On the second line, type y equals a times b to the power of x.
Yeah, thank you, right? So assuming you notice in here, make sure that the table says x1, y1, right? You see that x1, y1? On the second line in here, I'm going to type in the same, right? y1, that's y sub 1, okay? If you just type in y1, the 1 will become a subscript already. Are we good? Now that is a tilde sign. Right? You know where the tilde sign in here is? Above the tab button, right? So in here, shift, tab, right? That's the tilde sign. Now, on the decimals, so your keypads must have those, but in here, if you want to see where it is, click on the ABC. Beside the curly brackets, you have the tilde sign as well. So either of those will be fine, okay? And then type in what? A, B, right? Are we good? And then shift 6. That's the shortcut key for exponent, right? And then type in what? X1. Are we good? Alright. So once again, Y1, Y sub 1, tilde sign, A times B, raised to the X1 power. Okay? Again, for the subscript, you don't need to do anything. It's going to be automatic subscript. Okay? Now, last one, step number 4. Let's read that one in here. Kinsey, go ahead.
Rewrite the function using obtained A and B values.
That's it, alright? So what is your function now? Well, y, no y1 anymore. Y is equal to, what's your A? value on the parameter?
Five.
5. Very good, right? So just rewrite those with your given A and B values, right? So your A is 5 and your B is automatically 2, right? And again, raise this 2 to the x power. And as you may, notice in here, the graph in purple and the graph in green are basically the same graphs. Are we good, guys? So again, in here, we have 2 ways of doing that. Either do it algebraically or simply do exponential regression on your calculator. Are we good?